As you know, slurm is a very popular scheduler on HPC systems, and it has quite good documentation. That's not an issue, but basically you need to know your way around it. So it would be convenient to be able to use a large language model in order to interact specifically with that documentation. And this, of course, we can do using retrieval augmented generation, or RAG. Setting up RAG is not particularly difficult if you use AI chat. So we can create a RAG using the RAG subcommand and the name of the RAG we want to create, in this case just slurm. Okay, we're asked a couple of questions in order to initialize the RAG and generate the configuration. So basically we have a choice between embedding utilities, so either a more expensive one or a cheaper one. I'm going to go for the cheaper one in this case because, well, okay, this is taxpayers' money, so let's not do that. Okay, we also need to specify the chunk size, so this is 2000 tokens, and that is typically reasonable. So let's take this, and then the chunk overlay, so basically how much the consecutive chunk overlap in a way is set to 100. I can live with that as well. And now I have to add the documents. So basically, in this case, that would be the directory slurm docs. Okay, so AI chat has actually parsed all the HTML files, which I downloaded to this local directory, and now it is creating the embeddings. Okay, once that's done, I'm in this particular RAG, and I can ask questions about the slurm documentation. So AI chat comes with its own vector database where it stores these embeddings, so that is quite convenient. So this looks quite reasonable. The number of tasks is 64, indeed, that was the number of processes I mentioned. Then the CPUs per task is 4, that's correct again, because we are using 4 threads per process. The number of nodes is 8, and the number of tasks per node is 9. So indeed, each node can actually run 9 tasks, because each task uses 4 threads. 4 times 9 is 36, which is the number, of course, on the machine, so that is correct. And then, of course, if we divide 64 by 9, and that doesn't really turn out well, but indeed 8 is the minimum number of nodes which I would need. That would allow me to have 72 processes, but then again I specified 64. So this is quite a decent answer, and it also adds the distribution is cyclic, which I may or may not be happy depending on my specific application.